Okay. All right. So let's resume our lecture. So previously, we have covered LU1, lecture 1 and lecture 2. We talk about some introduction to statistics. What is statistics? Why we have to study statistics? And then some technical concepts in statistics for you to familiarize, like what is the types of data, quantitative versus qualitative data, and then what else? Descriptive statistics, inferential statistics. Descriptive is something to do with describing the data. Yeah. When we say inferential statistics, it's something to do with forecasting or estimation or prediction. Okay. And then we talk about what else? What else we have studied before this? LU1, lecture 1. We talk about parametric, non-parametric tests. Yeah? So as stats 1, this is stats 1. You're going to deal with parametric tests a lot. Then, so in the second part, last week we talked about what? Yeah, we talk about descriptive statistics, right? Summation, notation, and then some ways how to present our data, frequency distribution table, how you gonna construct table from the raw data, remember, raw data, and then we put it into a table, and we have two types of table, group table, and then non-group first, right? Non-group and group. Okay, so make sure you know what's the difference. And then we talk about histogram. Histogram is one of the ways how we're gonna present the graph, present the data. So it's a form of like this, something like on the bar graph, and you have to know what's the axis stands for. And then ogive. Yeah, ogive is something like a curve like this, sigmoidal curve. And you have to know what's the y and x-axis as well. Stem and leaf. So that's another way how we can present our distribution, right? It's based on stem and the leaf. And then percentiles and quartiles is like how we see the whole data, and then we divide it into quartiles. Quartiles is 25% or 1/4. Yeah, so like at 25% of the data, how the data looks like at 50%, and then at 75%. Okay, so that's quartile. And percentile quartiles also leads us to another way of presenting the data, that is box plot, which is constructed based on the information of the percentiles. Yeah, because this one, when you construct the box plot, like this one, so it has the meaning like this stands for what? This stands for Q3, this one stands for Q1, quarter 1. So yeah, these are all the ways how we can present the data. So sometimes you just have to choose from all of this which one is suitable. You don't have to present your data. Let's say you have your data from your research later. You don't have to present in all of the forms. You just have to decide which one is suitable. If it is enough to present the data in frequency table, that's fine. I mean, yeah, you don't have to do ogive. You don't have to do the same. You don't have to present the same data in different methods. So the reason why we have to know all of this is to let you know which one is suitable for your data. Sometimes some of the data is suitable to be presented in bar graph. Some are suitable to be in a pie chart, something like that. Okay, so that's what we covered last week. This is second part. Okay, so today we are going to cover, we are still in LU1, but we're going to wrap up LU1, still on descriptive statistics. But the focus for today, we're going to have a look at a measure of central tendency. and also dispersion. Okay, so basically like this is under each of these, there are some parameters that we want to focus on. For example, for the first one, central tendency, we're going to discuss about mean, mode, and median. And for the second part, dispersion, we will talk about range, variance, standard deviation, and I forgot something here, coefficient of variation. Okay, so let's have a look at the first part first. Measure of central tendency. When we talk about central tendency, and we are talking about data, like, let's say we have a set of data, right? And then the whole thing here, we call it distribution, distribution. Like the data, it can be of any type, like of anything that you measure, you study, okay? For example, collection of data on the size of insects, the size of trees, diameter of trees, something like that, or even what else? It could be anything, data. When we talk about data, it could be anything. And when we talk about the whole data that we have, for example, the diameter of head of bird, let's say bird, in Unimas, let's say you collect, you are observing the birds in Unimas because you are a zoologist. So your data is, there must be, certain number of data, and you must also identify that there are lowest point, and highest point of your whole data, right? You go what I mean? So it means that the whole thing here, which is covers from the lowest point to the highest point, the whole thing is called distribution. Yeah, distribution. Why is called distribution? Because it describes how the whole data looks like. Yeah, distribution. Yeah, so when I talk about distribution, it covers the whole data. That's what you should know. And then when we talk about a central tendency, when we have, this is like, first, remember when I say that when you have the data, whatever the data that you have, that is called raw data. The data that you just collect, and then you just gather them in your logbook. You don't do anything else. You don't categorize it. It's called raw data or primary data. Primary means it's first. Yeah, primary. Primary means first stage, something like that. Primary data. So, so in statistics, why you study statistics, you have to treat your raw data. When you treat your raw data, you have to calculate certain things, certain parameters, certain variables, right? So for example, what you have to do on the raw data, the easiest one, you want to determine what's the mean, the average, the median, the mode. So this is going to be covered under central tendency. Central tendency is like how the whole distribution looks like in the center, something like how it looks like in general, but talking about the central trend. What is the average trend? When we talk about average, mean, right? Average, mean is average. So it's something to do with the middle point of the whole distribution. Let's say you have lowest point and highest point. So what's the mean? The mean will actually sit in the middle, isn't it? Because it covers the middle point of your distribution. So that's the mean. So it's something in the center. Okay. Median is the central value. Let's say you have 14 points, let's say you have 21 points, for example, right? 21 data points. So it means that the data at the 11, if let's say you rank it in order from the lowest to the highest, the one that sits in the middle, let's say for 20, let's say 21 is easiest. So you'll see that the central point is at 11, is it? 11, right? So it will divide it into 10. So at 11, yang ke-11, okay? Let's say you arrange it from the lowest to the highest. So this 11 data, that is the median, right? You can see that it also sits in the middle. So that's why we talk about central. Central is in something in the middle. And then mode. Mode is something that is the point that has the highest frequency. Let's say you have, just now you have the data of the diameter of the head of birds in UNIMAS. So maybe at certain point, like when you measure, you have the same value that occurs more than once. Let's say diameter of bird's head, I don't know, maybe 20 cm lah, Shantu. Okay, 20 cm. It occurs like you measure, you discover that it occurs 3 times. Whereas other values, it occurs only once or twice, maybe less than 3. So this one seems to be the mode value. 20 is the mode value, the one that occurs the most. But also it's something to do with, you know, like it describes something that measures the it's something, yeah, it's something to do with related to the central kind of things. Yeah, so that's why it is categorized under central tendency. Okay, so I'm sure that all of these parameters or terms you have come across all of this, so it's just a revision for you. Mean is average, in other words, it is average. So to find mean, this is the formula. The sum of observation divided by number of observation. Number is n. The sum, it relates to the data. Okay, let's have a look. Okay, here last week we talked about summation, right? So you have to know what summation means. And in statistics, because we talked about, remember we talked about sample and population a lot, because we always refer to these two terms. Yeah, because we always talk about population, and population consists of many samples. So you have to know that, let's say, right. Okay, just now, let's say you study about, you want to find birds head diameter, okay, in UNIMAS. So it means that, I don't know how you're gonna measure, but maybe like something, you just focus on UNIMAS, you observe the birds in UNIMAS, something like that. So let's say UNIMAS is the population. Now, when you talk about UNIMAS, you have to know the area covered by UNIMAS, and you might want to, let's say for your study, you might want to set certain, what we call this, certain station that you want to define it as sample. Okay, let's say this site, like site A. I mean, yeah, in this case, this is, let's say, UNIMAS. Site B, maybe you measure the birds that may be available in site A, and then site B, and so on, C, D, E, F, G. Okay, so each of that is sample. So means that when you measure, when you observe the birds in site A, for example, so you must have more than one observation. Yeah, so ideally in statistics, we love lots of data. We cannot just rely on one data. It's not reliable. Eh? So you can also think logically. It will not represent actually UNIMAS ideally. So ideally we want to have more than one data for every sample. So it means that every sample would have more than one data point, right? One data point. So these are all the data that you collect from every sample of every site. So it means that every sample, it has sample mean, right? Sample mean. Yeah. So the mean for site A will be different from the rest. But also, when you calculate the whole mean, it will be population mean. This one is when we talk about UNIMAS. Just now we define UNIMAS as the population. So we also have population mean. Okay, so that's why in statistics, we are concerned with these two parameters, the mean of the sample and the mean of the population. So this is just an example. It will apply the same for other situations, okay? But it's just that you have to know these two things lah. So the symbol for sample mean is X bar. This is what I call bar. And for the population mean, the symbol is mu. This is what I call mu. So it's a Greek letter, mu, right? But you know the concept is the same. The summation of the data, right, divided by the n, the number of samples, the number of data in the samples, and the number of, let's say here it will be the number of, the total number of the n, like NA plus NB plus NC plus ND for the population. Okay, now let's have a look at this example. This is straightforward. You can, yeah, you can see that, you know, to calculate the mean, you just add up all of this information. This is the data, and divided by 10. 10 here is the number of the data. So let's say here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's why you divide by 10, you got this mean. Okay, and it's quite easy. And the same thing goes for here, right? You just add up everything divided by the total number. You got that mean. Right, now let's move to something more complex. Okay, so this is what we call like raw data, right? I mean, you have the data and it's not yet grouped into a table, so it's very easy to just calculate the mean. But if let's say you have a table, frequency table, yeah, so how are you gonna calculate the mean? Let's say, so this is the formula. Oh, what's wrong with my pencil? Okay, let's say this is the formula. The formula is the same still. Okay, so how are we going to apply that formula for this kind of data? So let's say you have the data, and then, or maybe you're given a data in the form of table like this. So this one is Ungroup frequency table, right? So it means that you can see that every class, every level, 200, 300, 350, you don't have the class. The class means something with the range, but this one doesn't have the range. So this one is Ungroup frequency table. So how are you going to solve for the mean for this case? So the x bar fx divided by n, summation of fx. So means here you have to multiply 200 with 6 plus 300 times 2, 350 times 2 until 950 times 1. And then that is the summation of fx. And you divide by 13. 13 is the n, the frequency, the total frequency. So 6 plus 2 plus 2 plus 1 plus 1 plus 1 equal to 13. So 4990 divided by 13, you got this mean value. Okay, so that's how you find the mean for the this frequency distribution data. Okay, so that's quite easy. And then what happens if, let's say, we have group frequency distribution like this? So instead of having one value for each level, you have the range, like 15 to 25, 26 to 36. And each of that, you have the frequency. So the way how you calculate the mean, you have to find first the mean value for every class. So let's say we move to this, right? So the original data is this one just now, this one, right? And then you have to create an additional column to find the mean value of each class. So the mean value is so easy. You can just find, you can just add up 15 plus 25 divided by 2. Like for this one, 15 plus 25 divided by 2, that's 40 divided by 2 is 20. So you have to solve for each of this, okay, the same formula. So that's the mean value. and it's the mid value that you have to multiply with the frequency. Means that 20, now you have 20 times 4 plus 7 times 31 plus until 5 times 64, right? And then the whole thing here you have to divide by 25, yeah, 25. So this one is actually this one, 1061 divided by 25, you got this mean value, okay? So you just have to find the mean value for each of the class. Okay, now we have what we call mean for relative frequency distribution. This is just actually an extension of this one. Okay, let's say this one is the original data, and then last week we studied about relative frequency. Remember, we study about how we're going to find, let's say, we know this one is the total and then this is the frequency. So relative frequency means that we divide the frequency with the total frequency. So here, 18 divided by 50 is equal to 0.36. 12 divided by 50 is equal to 0.24. So, and until the end. And if you want to know whether the values are correct or not, the summation of all these should be equal to 1. Okay, should be equal to 1. Why 1? Is because this one is in decimal point. So 1 actually represents 100%. Relative, this one is actually, if you convert it into percentage, is 36%. Okay. Okay, so now if let's say you want to find another way how you want to find the mean, you can use this formula. So what does this formula means? This is f divided by n, which is this one, and x here is referring to this value. Okay, so means once you solve f divided by n, then you just sum up all of the multiplication. 15 times 0.24 plus so until 25 times 0.08. Okay, the summation of this is equal to the mean. Okay, so you don't have to divide by n anymore because this one, the whole term here is actually this one. Okay, that's another way how you want to find the mean. Yeah. Okay, so what else? These are examples you can try by yourself. Okay, some of the examples. Again, the same thing, x divided x times this is the same thing. This is another example. Please have a look at by yourself. Okay, class exercise. This one, the mean height. Okay, the same principle. Okay, I leave it to you to do it by yourself, all these exercises. Okay, that's mean. And then median. So what is median? Median is the central value. Okay, central value means that, remember just now I talked about distribution. Distribution is, it covers the whole data that you have from the lowest to the highest point. Okay, so the median is the values that sits in the middle value, provided that you have arranged your data from the lowest to the highest. Okay, that's the first, that's the prerequisite. You cannot have your data scattered randomly. So in order to know what's the median value, you have first to arrange your data accordingly from the lowest to the highest. And only then you can identify what's the middle value. So what's the middle value means that here, this is 50% of the data. Yeah, 50% of the data. So that's what it means, like bottom 50 and the top 50. Okay, so when we want to find the median value, let's say we have the data points. There are two situations. The first one, if let's say we have the n, what I mean by the n is the number of data points. It could be even number, and it could be also odd number. Okay, so for example, if let's say the total n is 10, 10 is even, right? 2, 4, 6, 8, that is even. So let's say n is 10. So it means that you have 10 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is 1, this is 10. This is first. Okay, so now let's say you have arranged your data from the lowest to the highest. But whenever you want to find the middle value, there are two numbers, right? 1, 2, what's the values in the middle? 1, 2, 3, 4. It's this one actually, right? 1, 2, 3, 4, yeah. So this one, which is the 5th and the 6th. So that is the median. You cannot say fifth only because 6 also in the middle. So it's actually in the middle between 5 and 6, 5th and 6th. That's even number, whereby you have to consider the two values that sits in the middle. But for odd number, it's not a problem, because if let's say you have the number of the data is 11, yeah? N is equal to 11. So you have 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is first, this is 11. So it will sit in the middle. 1, 2, 3, 4, 5. So this is the middle. 1, 2, 3, 4, 5. So it divides equally. So the sixth data, the sixth, you know, yang ke-6, the sixth point is the median value. So for odd number, it's not a problem, but for even number, you have to find the average of the two values that sits in the middle. Okay. So yeah, so this is what is meant here. For the odd is this one. For the when the n is even, so you have to find the average of the values in the middle. Okay, so that will give you the median values. Okay, for example, let's have a look at this example. This is the data given. Okay, and you can see that it is already arranged in ascending order. Ascending means from the lowest to the highest, from 1, 7, 8, 10, 12 until 24. So the number here is how many? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. So n is 9, is an odd number. So it divides equally, right? This is actually the middle. 1, 2, 3, 4, 1, 2, 3, 4. So 12 is the median. Yeah, so 12 is the median value. But what happened when it is even number, like n is equal to 10, okay, so this is the distribution. So you can see that the one in the middle is 2, 3, 4, 1, 2, 3, 4. This is the one. 1, 2, 3, 4, yeah. It's okay. Oh, no, it's not yet. No. This one, okay, you can see that this one is not arranged yet. This is not arranged yet. So you have to arrange first. So as I said just now, the first thing that you have to do when you want to find the median value is you have to arrange your data according to the ascending order, yeah, from the lowest to the highest. Okay, don't forget that. Otherwise, you cannot find the median value. Okay, so once you arrange it from the lowest to the highest, then the values in the middle is 12 and 15. Okay, so the median value is 12 plus 15 divided by 2, that's 13.5. So that's the median value. So you can see that the median value here is, it doesn't actually exist in all the data because it's the average of the two values in the middle. Unlike the first one here, 12 is, you can see 12 here. Okay. All right, so that's median. Okay, the next one is mode. Mode is defined as the value which occurs with the greatest frequency. Greatest frequency. Okay, let's say we have this example. This one, and this one. So you can see that the one that occurs with the greatest frequency, this one, right? Because it occurs 3 times. The rest are only twice for 2 and 4, and only once for 5 and 7. So the mode value is 6. Okay, don't get confused. Here you can see that the frequency is 3, right? Don't sometimes some of the students might confuse when you say when there are 3 times, the mode is not 3. The mode is referring to the values of the data point. Okay, so the mode here is 6. Okay, remember? Right. So the second one here, this one is the so sometimes there are 2 mode values. It can be more than 1. So for example, in this case, the mode are 3 and 4. And also mode, there is a situation where mode does not exist. For example, here, all of them occurs only once. So there's no frequency more than 1. So it doesn't exist because all are equal. Okay, so that is mode. You can have a look at the examples by yourself, right? For example, this one is the frequency, the highest frequency. See, so when it is asked what is the mode, don't answer 6, but you answer the value of the value that the value of the data, which is 200 in this case. Okay. So it could be confusing if, let's say, it is in the form of table like this. When when the students see this one is 6, I mean the one that the highest one, they would tend to answer the mode is 6, but actually it's not. The mode is 200. Yeah? The mode is this the X value. Okay, that's a mean, median, and mode. And among all of this, the most common one is mean. So that's why in anything you can see the data, whatever the analysis, people will tend to say about the average, because that is the easiest way to describe the distribution. When we talk about mean, it's very easy. Okay, the mean is the average income, average weight, average height. It's very easy to visualize it, to interpret it. Okay, right. So these are all the exercises that you can do, try by yourself. Okay. The second part is the measure of dispersion. Okay, when we talk about dispersion, we have to understand first what is dispersion. Dispersion means how we are still talking about the distribution, the data, the whole data distribution, the whole thing of the data we refer it as a distribution. So the distribution, the dispersion means like how dispersed the distribution is from the mean value. Let's say we have the mean value, right? The mean value. It means that we want to talk about, let's say we describe it in the form of graph like this. Let's say this is the mean value. And this one is actually the whole distribution. This is mean, there's a mean. And this is distribution. So whether it's something like this, or maybe it's something like this, or something like this. So you can see different shape of this, like this and this. That is actually the dispersion. That describes the dispersion. Means that how to say that? How spread it is. Okay. Let's say we talk about range. Range is the easiest. Like when you talk about the whole distribution, the distribution of marks, for example, marks of statistics marks in group 3. Let's say I found out that you guys score between 60% to 95%, let's say. Okay, so that's the lowest is 60 and the highest is 95. So that is the range, right? The range. But I need to know also what's the mean value. So what's the mean value for 60 plus 95 divided by 2? 78. So the average, let's say 78. Okay, 78. So it means that if I want to draw the distribution curve, it's something like that. Okay, so what happened if, let's say, in another group, I have one group with the range from 70% to maybe 80%. Okay, so it will be different. It will be something like that. And here, the mean will be not 78, the mean will be 75. So you can see that the range is getting narrower for the second group, right? So this one, this is group 2. Let's say this one is group 1. So the range, it will determine the dispersion, like how, if let's say you can see like this one, the dispersion is very narrow. It's only between 70 to 80. All the students got the marks between 70 and 80. But in group 3, let's say, it's from 60 to 95. So means that is more spread, much spreader in terms of the distribution, right? Okay, so that is actually, that actually describes the dispersion. If you want to understand what is dispersion, that describes the distribution, the pattern of the distribution in general. So when we talk about dispersion, there are few parameters that we can look for. Okay, the easiest one is range. Okay, so you know what is range? Is it denotes the range from the lowest point to the highest point. Okay, so whenever you have the data and then you have identified the lowest and the highest point, for example, just now I discovered that the marks range from 60% to 95%. Okay, so based on this information, okay, I got an idea that there's no one got below 60, there's no one got above than 95. And all of the students score between these 60 to 95. So the importance of it is that, you know, you have the idea about it. Yeah, so that is range. And it shows that the distribution is between that particular limit, right? Another way how we want to describe the dispersion is variance. And we go first, later I'll describe each of these. And then we also have standard deviation and coefficient of variation. So variance is, yeah, let's have a look at range first. Okay, range is very straightforward, right? Lowest and highest. So it's denoted by U is the largest measurement, the highest, and L is the smallest. Okay, I think this is, you know, let's say, for example, 10 to 26. 10 to 26. But what we do not know, whenever we are given like range, just now, let's say I was given an information about the marks 60 to 95%. That's the marks that the group, all the group's members got. But I do not know something inside it, right? I do not know like how, what is after 60, what is the marks after it, you know, like it could be, for example, let's say if you are given like a range, in this case, 10 to 26, there could be various possibilities of the distribution in the middle. Like for example, maybe there are 14, 18, 22, but there are also 17, 18, 19, 19. But this one, because it sits between 10 and 26, you know, like if you're just given an information that is from 10 to 26, you do not know actually other information inside it. So it means that range is good, the information of range is good, but it is limited in that sense. We do not know anything between that, okay? So that's why in statistics, we need to find more than range, yeah? Because range might not be enough to describe the distribution. Yeah, sorry. So the second parameter is variance. Variance is defined as, let's have a look at the definition, the average of the squared deviation scores, and is denoted by sigma square. This symbol, we call it sigma. So what is meant? So let's say we have this distribution just now, and we have identified the mean value. The mean value, let's say we denote mean as x bar, okay? And we have the data point x1, let's say x2, x3. This is referring to each of the data point within the distribution until xn, let's say x 12 maybe, yeah? So let's say 12. So the variance is defined by, we know the mean, and we have to find the difference between x1 and x bar, and then the square value of it, okay? For example, this one. And then followed by x2 minus x bar square plus until the end of the distribution. So variance is the summation of all of this. Okay. So that's variance. Okay, let's have a look first at this one. Okay, the symbol just now is sigma. This one is referring to population variance. So remember, when we talk about statistics, we have to also consider sample variance. So this is population. Sample variance is denoted by S square, but actually the concept is the same. You add up all of the, you know, like this one, the difference of the difference between each data point with the mean value, and you sum up all. Okay. So that is the sample variance, population variance. Okay. So you have to remember this formula lah. Frequency. There are few formats, like for example, if you have relative frequency data, you have to use this, and then group frequency data, you have to use this. Sample variance, you have to use this. Okay. Okay, let's have a look at this example. The weight of 100 seeds are this one. Okay, this is the data. Calculate the variance, the sample variance. So means that the first thing that you have to find was the mean. Okay, 65. Let me just find directly from here. And then you use this formula. So it means that you have to know n is 5, 1, 2, 3, 4, 5. And then you know what's the x bar, this one. And then you can apply this formula, 1 divided by this. And you have to find this one. This one means that 69 minus 65 square, yeah, like this one, 69 minus 65 square plus 67 minus 65 square, each of these actually, plus until 63 divided 65 square. Okay, and the whole value here is here actually, this one, 34. Okay, so that's how you apply the formula and you got this value. Okay, yeah, this one is actually the same way of this one. It's just that you is a different form, but it actually carries the same answer at the end. It's just different format, like you masuk ni dalam ni, and then at the end you got n-1 as the denominator. But you just apply each of any of this type lah. It would give you the same formula, the same value. Okay, all right. That's variance for group data. This one, it depends on what kind of data that you are analyzing. Okay, if you are just analyzing just now, like simple data, then you just use that. And then for this one, you have to refer to the formula for the group data, which is this one. Okay. For example, how to use this formula. Let's say you have this data. The n is 50, right? So that's how you got this. And then each of these, you have to refer to the mid-class point. Yeah. For example, here, the midpoint. Remember, like when you want to find the values for this one, you have to find the mid value. And then that is the value that you have to, that represents the x, yeah? X. So what point here, this one, it refers to this one actually. So x bar, you have to find the x bar first, right? And then, for example, 97, for this one, 97 minus 80.6 square, that will give you this value. And you have to find for each of these, because you need to add up everything to form this term. right? Because you have to multiply with F for this one. And then that will give you the values for the term inside this formula in order to find the S square at the end. Okay, so what I can say is that you have to apply a different formulas of variance for different types of data. For example, this is group data. Just now, this one is group data. Okay, just now we talked about this one is ungrouped data or sample variance, right? Which is much simpler, the formula. This one is actually any sample ni adalah ungroup data, and then we have group data, and we also have relative frequency data. So it depends on the types of data that you are analyzing. Okay, so this one is relative frequency data. This one formula. It's just that you follow lah ni benda ni, term ni, apa benda yang it represents. So you have to create the column first, right? And substitute correctly. Okay, so that is variance. So standard deviation is another way how we can describe dispersion. Okay, so it's related to variance because if let's say just now variance is S square for the sample variance, the standard deviation is actually the square root, the positive square root of the variance, which is S. So the sample standard deviation, the symbol is S. Okay, and for the population, the standard deviation is sigma only. So just now sigma square is the population variance. Yeah? So when you find the square root of it, it gives you the population standard deviation. Okay. So it's just that in statistics, standard deviation is more common to be used. For example, like when we describe the data, let's say the average is 60, let's say average of marks tadi kan, let's say average of marks 78%. So you would see that in any report or paper or journal, it will be followed by the values of the standard deviation. Let's say 78 plus minus maybe 4. Okay, so it means that it shows that from the mean, how much the dispersion of the data will be actually. So that is what the standard deviation describes. Okay, all right. So when you find this variance, you can actually find the standard deviation directly once you find the square root of the variance values. Okay, so there's nothing much to be described here because it's actually continuation from variance. So here. Okay, and the last one is coefficient of variation. Okay, just now when we talk about range is something from the lowest to the highest, like 65 to 95. That is range. And then when we talk about variance is a single value. It's like, for example, maybe 35, 40, something like that. And how we want to know whether which one is for variance, we have to compare the values, like 35 and 40. 40, it means that the dispersion is more. Okay, and the same thing goes to standard deviation. Whenever you have standard deviation, you have to compare with another value. Let's say standard deviation for sample 1 is 5, and for the second one, sample 2 is S1, S2 is, let's say, 10. So you would have an idea that sample 2 would have more, the data is more dispersed. Dispersed means like more spread. The spread is much bigger, okay, when you want to compare this one and this one. But if let's say you just have a single value like 10, but you don't have anything to be compared with, it's a bit tricky for you to have a picture. Is it 10 is good or not? Something like that. Okay. So the fourth parameter here, is called coefficient of variation. So how it differs from standard deviation? So it is normalized, meaning to say that it is, let's say here, this is actually the standard deviation. It is normalized over the mean value, okay, the mean, okay, and multiply by 100. Okay, let's say macam ni. Let's say you got marks, let's say out of 50 questions, you got like 40 over 50, 40 correct answers, okay, over 50. But let's say I don't mention about there are 50 questions. I just say that you got 40, but of course you do not know that it's not 40%. You do not know that 40 of what? 40 of what? It's incomplete, isn't it? Unless if you have, let's say student A got 40, but I don't mention is about of what? Of 50 questions or 40%. I don't mention anything about it. Let's say student B. Student B got, let's say 30. Okay, you can compare between A and B. Okay, A got much better marks. Okay, but you know that's the only thing that you can say. But if let's say you only know about student A got 40, you don't have much idea. 40 of what, isn't it? So unless if I give you, say, if I give extra information, or if I give if I normalize, I say that normalize means that I put it under per 50. Let's say per 50 you got 40, and you multiply with 100, you actually got 80%. So actually in this case, the value of 80% is more meaningful than just the value of 40. No, because you don't know 40 out of what? 40 of what? It should be of something, okay? So this is what is how you can relate with CV if you want to compare with standard deviation. S is only, standard deviation is only one value that we do not know, like for example just now 5 or 10. We do not know how good it is. Like 40, how good it is, how good 40 is. Is it good? Is it bad? Okay, unless you normalize it. When we say normalize, is we make it over something. Okay, we make it over something, then we say it normalize. Normalize. In it's not mentioned here, but is actually something common in statistics or maths lah. We say that we normalize the value over something, then we know it is actually what. Okay, so the same thing, like how you relate here. CV is the percentage of the standard deviation over 100. So it means that rather than if let's say you want to compare just now 40 and 80, 80% you got better idea, right? So the same thing goes to coefficient of variation. It is in the form of percentage, okay? Percentage. So it means that it is more meaningful than the standard deviation values. Okay, that's why we have this. You can see that from the range just now, right? From the range, variance, standard deviation, and until coefficient of variation, you can see coefficient of variation gives better idea than range. Range, we do not know how is the dispersion. We just know the lowest and the highest, but we do not know how the pattern inside, isn't it? So that's why we have this kind of parameters. We can use it accordingly in statistics if we want to describe our data. Okay, so coefficient of variation, let's say you have the information of standard deviation like this, standard deviation of 1.1, and then you know the mean is 3.2. So based on the formula just now, S divided by the mean multiplied by 100. So for stock A, this is example, the coefficient values is 34%. So means here, okay, let's say you compare with stock B, it's only 8%, and the value here is okay. So it means that it gives like more more sound, just a comparison. Okay, let's say if let's say you want to compare, for example, in this case, you want to compare stock A and stock B. You want to compare how much the deviation of one stock when it is normalized with the mean inside it, okay, compared to another stock that is, you know, according to its mean value. For example, here is stock B. So from here you can compare because it both of them have been normalized accordingly. Okay, but if let's say you just have the information of standard deviation of this 1.1 and 5, it is not fair actually for you to compare, because stock A has different types of distribution and stock B has different types of distribution, which means it has both of them have different mean values. Okay, so by normalizing it over the mean value of whatever the sample it is, and only then you can have a fair value at the end that you can compare with each other. Yeah, I hope you understand what I mean. Okay, see, comparing standard deviation is not a good strategy. See this one, this statement. So that's why we have to use this coefficient of variation. So that's the importance of it. Okay, so these are examples that you can go through by yourself. Any question? Oh, skewness. We have another one. This is just a concept lah. Okay, skewness. Skewness is a way how we want to describe the distribution. Okay, remember when I say about distribution, at the end you want to say how the pattern of the distribution, your data distribution is. So there are many types of distribution pattern. The most common one is this normal distribution. Why normal distribution is the most common one? Because as I said in my first lecture, the nature of distribution in this world, whatever distribution in this world, it will follow the normal distribution. Actually, this is based on observation. It's not I said that, but it's based on the observation. Average values will sit in the middle. I mean, it will, as I said lah, macam, let's say when we talk about whatever, let's say marks, okay, not many people will score very, very well, like 99, 98, very few, they are maybe, but they are few. They would sit here, let's say 90, let's say we talk about marks, 98 to 100. Ada lah, but maybe 1 or 2%. And not so many people will also fail. For example, less than 30 marks, maybe 1 or 2. But the average of the students, let's say, in any test, it will got between maybe 70 to 65 to 75, maybe lah, macam tu. So that is the trend in anything, not just in marks, in height, in weight, in whatever. Okay, so this is based on observations of many people. So that's why the scientists, the statistician, they come up with a fact or theory saying that many distributions in this world will follow normal distribution, and it will be more apparent when the number, the n is bigger. Let's say the n is 1,000 people. So based on the observation of 1,000 people, let's say, the average will sit in the middle and it will follow the bell curve shape. Yeah, okay. So that is one fact that you have to know in statistics. And it's very, to me, it's very amazing lah. I mean, why everything must follow the bell curve? It's something very, very curious, very interesting to accept. Yeah, you have to accept, but it's something, you know, it's something interesting also to ponder about it. But that is the nature of whatever the distribution. When I say distribution, is whatever data in this world. Okay, so this is the most common type of distribution of the data, and we call it symmetric or bell shape. Okay, but also we have other types of distribution. Let's say in some circumstances where especially when the n, the number of the data is not that much, maybe let's say n equal to 10. Sometimes it could follow the bell shape, but sometimes it could be something like this. It could be like skewed. We call it skewed to the left. When it is skewed to the left, it means that this is skewed. This is So instead of like this one just now, when we say here, the mean, median, and mode, it sits in the middle, okay? And it divides the distribution equally, 50-50. But when we have this kind of skewed left, skewed negatively, so now you can see that the mean, median, and mode, they are not at the same point, but you can see that the mode is, of course, the peak one, because this one refers to the frequency. So the peak is always the mode, right? And you can see that the mean value is less than the mode, because the mean is always referring to the middle point of the distribution. So the mean is here, right? And you can see that it is less than the mode value. That is when it is the distribution is skewed to the left. When it is skewed to the right or positively, so means that positively means that the more positive is the one that goes to the right of the x-axis. So that's why this one is skewed to the right or positively. So in this case, the peak is less than the median. Okay, remember this is the range. The median is in the middle, right? The mode is the peak value, and you can see the mode is less than the mean value when we talk about x. Yeah, so this one is mode, kan? This one is mean. So mean is less. The mode is less than the mean value, but median is in the middle. So you can see that trend. Yeah? So this is the two types of distribution apart from the symmetric distribution. Okay, so yeah, so you would see this kind of things more often when the n is less. When in statistics we define n, sometimes some people say 30, some have different definition, but when it is more than 30, it will tend to follow the normal distribution. But sometimes it's not, but most of it. We cannot say every distribution, but most of it. But in some circumstances where the n is less than 30, like 10, only 5, so it tends to follow like non-symmetric distribution. So when it is non-symmetric distribution, it's either skewed to the left or skewed to the right. Okay. Okay, so these are some exercise for you to find the mean age, variance, standard deviation, coefficient of variation. Okay, you can do it by yourself. Right, so that's all about LU1. So we talk about today the central tendency, the mean, mode, and median, and also the dispersion, the range, variance, and standard deviation, and also coefficient of variation. Okay, can we have a 10-minute break? And also we have skewness at the end. Yeah, can we have a 10-minute break? Because we have another part that I want to cover today.
Yes.
Okay.
Yes. Shorter.
Huh?
Yes.
Okay. So I'll see you guys at 12:17. 12:17, 10 minutes from now. Okay, guys, we continue. I'm sorry if every lecture might be a bit long because I don't have choice for that. Our LU is very very packed, and I'm afraid that if I don't follow it, you know, we can't cover the topics on time. Because for our target now is we have to cover LU2 before the mid-semester exam. So that's why I have to a bit rush. For LU2, there are 7 lectures, if not mistaken. So it's quite long. So here we're going to kick off LU2 with the first lecture, right? Okay. So LU2 is about probability distribution. So we are done with LU1. LU1 is just a very short LU. So LU2 is a bit longer. Please bear with it. So the first lecture here is about probability distribution. Distribution, as I said, is about the data, the whole data, and we refer it as distribution. Probability, do you know probability? Is the chance?
Yes, doctor.
Yeah. So probability is something to do with the chance, the probability. What is the probability of winning the game, for example? 50%, 50-50, or maybe 70%. Yeah? So it's about the chance. Chance, or in Malay we call it kebarangkalian, the chance. Okay, so under this lecture, we're going to cover observed and standard distribution. And then the second part is binomial distribution, and the third part is Poisson distribution. Okay, first let's have a look at some introduction. Okay, what is meant by observed distribution and standard distribution? Observed distribution is something to do with what is derived from the data collected. For example, just now, I give in LU1, we talk about so many examples of data that we collect from certain types of survey or studies, right? So it's from the data collected, whatever we discuss or we analyze it. That kind of distribution is observed distribution. It's something to do with the data collected. Okay, so there is another type of distribution which is called standard distribution. Standard distribution is a distribution that is generated mathematically or theoretically. And how the easiest way to know the standard distribution, we are going to refer to tables, standard tables a lot. There are so many tables that we're going to refer in statistics. And whenever you see that it is based on tables, that is an example of standard distribution. So just now when we talk about observed distribution, like from the data that we collected, we don't refer to any table, right? Table means the values that have been generated by statisticians in the past based on their observation, based on certain formula or theories, okay? But before this, we don't, I mean, in all the examples that I've showed to you, I don't refer to any tables, right? So that's one of indicator saying that that kind of distribution is an observed distribution. It's not standard distribution, okay? So under standard distribution, there are 2 types of distributions, discrete distribution and continuous distribution. I think I mentioned about these 2 terms in the previous lecture. Discrete is something to do with whole numbers. There's no decimal points. So discrete, yeah, whole numbers. Whereas when we talk about continuous, it's something about continuous values. Like there is no, like, yeah, 1.1, 1.2, 1.3, that is an example of continuous numbers. The easiest way to remember is with decimal points. So under discrete distribution, we're going to talk about binomial distribution and Poisson distribution. Yeah, we are going to cover that today. For continuous distribution, that's under normal and t-distribution. We're going to cover that in the next lectures. Okay, let's have a look at observed distribution first. Okay, observed is something that just based on whatever the data that we collect. Okay. Okay, I think this one, when we have the data, sort the data, arrange the data, And then we can use frequency table, maybe have covered in previous lectures. And we can use certain ways to present the data. We can use histogram, we can use GIF, stem and leaf plot, right? And then when we talk about those things, remember when we find the frequency, the relative frequency, for example, we divide the frequency with the total frequency. That is actually refers to the probability. The probability. Let's say you have the frequency of 5 and then 1, 7. Let's say this is X. It has values, and let's say the total is let's say another one, 2, 7, 2, 9, 15, right? Okay, 15. The total is N is 15. So when you find the, let's say 5 relative frequency, 5 over 15, that is actually referring to the probability. But previously we don't mention about probability, but that is actually probability. It indicates the chance of that particular X to occur during in the distribution, in the whole distribution. Okay, so this one is P is probability, the frequency divided by total frequency. Yeah, so we cover this. Yeah, so that is the simple probability. Yeah, so let's say here frequency is given 1, 2, and when you find the probability is you divide by the total number. 1 over 40 is 0.025. This one is 2 divided by 40 is equal to 0.05. And how you want to know whether the values is correct or not? The total of all of this, yeah, if you total up, it should be equal to 1, which is 100%. Okay, so 100% is like percentage, the whole percentage. Like you have, let's say 50% of winning, 50 out of 100%, right? So it means that the probability is half. So that is probability, okay? And if you, let's say you want, this is actually the individual probability. But let's say if you want to find, and it has classes, if you see here, classes. But if let's say you want to find something that covers more than one classes, for example, this one, 20 to 29, you can just refer to its individual probability, which is 0.1, isn't it? Because this one is 0.1. Okay, let's say you want to find like the probability of length from 20 to 49. So it means that it covers until here. So what do you have to do? You have to add up all of these values. 0.1, 0.25, 0.4, 0.75. So these values. Okay, so depending on the situation that you are analyzing, so that's how you deal with the probability of the observed distribution. Okay, so this is another example. The difference is just in terms of the classes. Here, you can see that it's less than. So when the question asks, it could be like, what is the probability of less than 59? So it means that you have to cover the whole probability here. Let's say here, let's say what's the probability of less than 59? Then you have to cover all of this, because it means that anything less than 59, it starts from all of these values, for example. Okay. This one is more than, yeah, the pattern is more than. So when you say the probability of X more than or equal to 30, so it means you have to cover this, and this. Okay, so you have to think logically in any situation that you are analyzing. More than 30 means it up to 60. It's not just only this one. It's not just only this one, right? Okay, so that one is you have to think logically. Okay, all right, so that is observed distribution. That's quite straightforward. I think you have covered, you have studied probability in your school as well. Yeah, so it's just a revision for you. Right, now we move to the standard distribution. Okay, when we say standard distribution, we want to relate whatever the things that we calculate with the values or the values in the table and how those tables are generated. Those tables are generated based on certain formulas that have been invented by statisticians in the past. It's not from me, I'm just delivering to you. Okay, if you ask me how these tables are created, I don't have the answer for that. We are at the point that we just have to accept the formula created by statisticians, by previous statisticians. How they create it, they have done research, they have done observation, like maybe 10 years observation, they come up with one formula. You want, if let's say now, let's say we want to, whether we want to test whether the formula is correct or not, we cannot just say that, oh, this formula is not correct, we cannot accept it. You cannot just say like that, you know, you have to challenge it, and how you want to challenge it, you have to do 10-year work. So it's not easy actually for them to come up with the formulas, with any table, with any concept. So what I can say that at this point, we just have to accept lah. Macam mana, like how you accept all the scientific principles, when you say that DNA it consists of ribose, it consists of this and this. You know, we cannot challenge those facts. We just have to accept, right? If you want to challenge, you have to do investigation. You have to prove that it's not ribose, for example, something like that. So the same thing goes to maths or to statistics. Okay, so you have to understand that the role. What is our role? We have to understand what previous statisticians have introduced. But it's good to have the curiosity. I would say it's good, but to challenge those things, it takes actually a lot of works. Yeah. Okay. So if you ask me how people come up with this binomial, why not trinomial? Bi means it only covers two. I don't have the answer to that. Okay, because I didn't do any research in statistics. Okay. So just to say that, yeah, they are created. These things are created by statisticians based on their established research. Okay. Now we move to the standard distribution. Standard distribution, as I said just now, is based on tables. So if you go to ELIT, I have uploaded two tables: binomial table and Poisson table. So those tables are used for us to solve the binomial distribution and also Poisson distribution. Okay, so this binomial and Poisson distribution, they are among the earliest distribution introduced by the statistician, and they are discrete distribution. Discrete means it involves whole number. It doesn't involve any the values. Yeah, the values are not continuous. Okay. So for continuous, we are going to cover it next lectures. Okay, now let's have a look at binomial distribution first. So when we talk about binomial, we have to understand binomial, it means what? It means it deals with two outcomes. Bi means two. So it means that when it's two, the probability, when we talk about probability, it should be 50-50, isn't it? Let's say true, false question, true, false question. So you just have to answer either true or false. So if let's say you answer true, the probability is 50% correct. Or if you answer false, it's another 50%. So it's divided equally, right? If let's say you have multiple choice question, you have 4 answers. So the probability of each answer to be correct is 25% because you divide by 4. So if it's true, false, it's only 2, right? 2 outcomes is 50-50. Make sense? So that's why, and true, false is an example of binomial probability because it deals with only 2 outcomes. For MCQ, it's not. It's because it has 4. Okay. So in our data, we at certain point we can have this kind of 2 outcome situation, whether it has, for example, it has the what in science. Let's say it has the fur or not, yes or no, or maybe not fur lah. It has apa ya? It has the membrane or not, let's say in bacteria, right? It has vacuole or not. Yes or no. So the answer is yes or no. Yeah. So we don't have like in the middle. Maybe some situations have in the middle, but there are some situations that there is only yes or no. So the probability is 50-50. So in that situation, we have to use binomial distribution principles to analyze the data of that situation. Okay. Okay. So this is this is about skewness. Let's have a look at the So a binomial situation can be recognized by the following characteristics. As I said just now, it's yes or no, success, failure, true, false. Anything that has two outcomes. So that kind of situations is binomial data. Okay, sell or no sell, agree, not agree. With flowers or without flowers, yeah, something like that. And when we want to define, let's say we talk about success and failure, okay? And the probability of success, we denote it as P. And of course, the other one, because we know that 100% is the total total percentage, right? I mean, when we convert it into decimal point is 100% or 1 decimal point. So if let's say P is 35%, or in decimal point is 0.35. So of course, the probability of the other one, it could be 1 minus P. 1 minus 0.35, that is 0.75. So you can determine the probability of another event based on the information of one event. Okay, sometimes it's not always 50-50, sometimes it's maybe probability is 30-70, 40-60, but you can determine it from the information of one event. Okay, right. Okay, let's go directly into the formula. So this is the formula that have been invented by statisticians, and they claim it suitable for binomial probability. So the formula is NCR P to the power of R multiplied by 1 minus P n minus R. So what each of these means, NCR is the factorial actually, combination, this one. So it means, so you see n, R, okay, let's have a look at what n is. N is a sample size. R is the event that you are analyzing. Event to be analyzed. Okay, later when we go into the question, we could see the R value. Okay, P is the proportion of type 1 population, or the probability of event or type 1. Okay, sometimes it's given in the question. Now, when you know that what is P, what is the probability of type 1, and then of course you know what is proportion of type 2, which is 1 minus P. Okay, 1 minus P. Now, what else? Okay, now NCR refers to this one. You have N as the subscript. We call it the one in the on top to the power tu, macam to the power tu is subscript, and the one down here we call this one is superscript, and this one is subscript. That's the term lah, right? So when we have NCR, it means it is equal to N factorial, you know factorial, right? And then R factorial, N minus R factorial. This is a formula for anything that is NCR. I think it's covered in AdMaths. So it means this one, okay? So it means that if let's say you have 3 and C maybe 2, okay? So it means that this one, it means 3 factorial divided by 2 factorial, because R is 2, and N minus 1, 3 minus 2 is 1 factorial. Yep. And you also have to know certain values of factorial. Let's say 0 factorial, it means 1. Yeah. So, and factorial, what does factorial mean? This is what we call factorial. Factorial. I hope you will still remember. Factorial. So factorial means when we say 3 factorial, it means 3 times 2 times 1. It's until 1, the multiplication. 2 factorial, 2 times 1. So 5 factorial, 5 times 4 times 3 times 2 times 1. Yeah? Okay, so that's what factorial means. Okay. So this one, this factorial, until 1, yeah. Okay, so this is the formula of the binomial distribution, binomial probabilities. Okay, let's have a look at example. How are we going to apply this formula? Okay, this formula will be given in the exam. Okay, any formula in statistics for this course, it will be given, but you have to know how to use it and when to use it, because it's not stated in the formula that this is binomial or this is to be used under this, and this. No, you have to know by yourself. Okay, and how to know by yourself? You have to familiarize yourself with the questions. So when you come across this question, you know that this is a binomial probability, and you know that you have to use this formula, because we just give you the formula in the list of many formulas, and you just have to select the formula. Okay, and you have to know, like, let's say n refers to what, r refers to what, so that one you have to know by yourself. But the whole formula you don't have to memorize. Okay, let's say I write down the formula just now, NCR, PR, and 1 minus P n minus R. Okay, so this is the formula. So how are we going to apply in the question? Okay, so from past records, the prop that a machine will need correcting adjustment during a dispersion is 0.2. If there are 6 of these machines running on a particular day, find the prop that no machine, just 1 machine, exactly 2 machines, and more than 2 machines. Okay, so first we have to identify from the questions what is the parameter, what 0.2 means, what 6 is, what is what. Okay, so here you see the probability that it will need correcting is 0.2. So it means that we define that as type 1 event, or we can say that P is 0.2. So means P is 0.2. Okay. Now what is 6? 6 is if there are 6 of these machines running, so 6 means n, means that the whole number of the machines are 6 in this case. So we know P, we know n. So each of these, like the first question, no machine, 1 machine, no machine, 1 machine, 2 machines, and here is more than 2 machines. So each of that is actually the R, the thing that we want to analyze, the event that we want to analyze. Okay, for example, for the first one, R is equal to 0, second R equal to 1, R equal to 2, and this one is R more than 2. Okay, so how are we going to solve this question? So this is the formula of binomial. So how you know that this is a binomial distribution? Is based on, because after this we're going to cover Poisson. Poisson is actually an extension of binomial, and Poisson is used when the n is more than 20. So it means that for anything that is less than 20, we use binomial. Okay, I don't mention in the characteristics of binomial before, but it's actually, when you see this one, you see that will need correcting. So it means that it involves 2 events, correcting or not correcting. So from there you can predict that this is a binomial distribution, and apart from the n number is 6, which is less than 20. Okay, so that's how you know that it is actually, it needs binomial distribution or probability. So here, let's say we solve the first one, R equal to 0. So applying this formula, so the n is 6, C 0, okay, and P is 0.2. We just substitute based on that formula. R is equal to 0, yeah, and then 1 minus P is 1 0.8 lah. Yeah. 1 minus 0.2 is 0.8. 1 minus P. Okay, 0.8. N is 6 and R is 0. Okay, so it will be, so anything to the power of 0 is 1, isn't it? This is 1. So NCO multiplied by 0.8 to the power of 6. And for this one, you have to know that it stands for n factorial divided by r factorial, because r is 0, 0 factorial, n minus r, 6 minus 0 factorial, which is actually 6. And you have to know by yourself that 0 factorial means 1. 0 factorial means 1. This is the principle of factorial. Okay, it will not be given in the formula that 0 factorial is 1. You have to know by yourself. So now knowing this one is equal to 1, this is 6 factorial, right? You can cancel it out. So it's actually equal to 1. So this one is also equal to 1. Okay, so at the end, you just deal with 0.8 to the power of 6. That gives the value of this one actually, 0. Yeah, so this is the solution, 0.2621. Okay, so that's how you reach these values. And for the second and the third question, it's the same way. It's just that you are substituting the r value. Like from here, this is 0, right? This is 1, this is 1, and this one is n minus 1, n minus r, which is 5. Okay, this one is 2, 2. Yeah, so that's the difference, and that's how you got this value. Okay, so because you're just changing the r value. Okay, now the third question, the fourth question. What is the probability? Now every of these we are talking about probability. Probability. See this one? Probability. It means that the values should be, if you notice here, these values, it should be less than 1. It cannot be more than 1. If you got 1 point something or 2 point something, there's something wrong with that, with your calculation, because it must be less than 1, less than 100%, because this one is actually in decimal point. So if you convert it to percentage, it's 26%, 39%, 24.56%. Okay, so that's one of the hints. Probability, anything must be less than 1. Okay, now move to this question. More than 2 machines need correcting. So now we have 6. The n is 6. N is 6. And then you have the probability of when it is 0, r equal to 0. Probability r equal to 1. Probability r equal to 2, right? Because you have this value, this 0.2621, 3932, 2.2458. And then now you want to know what is the probability of when it is more than 2, which means it starts with 3, because this is a discrete. Remember, this is a discrete distribution. So there is no 2.1, 2.2. So that's why we start after more than 2, it must be 3. It's not 2.5. Okay. So the next one is r equal to 3. So since it is until 6, it means that we need to know actually what is the this one, r equal to 3, r equal to 4, actually r equal to 5, and r equal to 6, isn't it? So if let's say it says that more than 2 machines, we don't say that it's only 4, it's only 5. So it means that we have to actually sum up the probability of this, and until 6. Remember when I mentioned just now, you have the table. When it says more than, let's say more than certain number, you have to consider everything is after that, right? Logically, because it's logically everything after that. Yeah. So for this one, it's the same thing. Actually, if let's say it asks you more than 2 machines need correcting, you have to sum up this, and this. Sum up the probability. That's one way. Another way, since we already have this information, and we know that it's until 6. So another way, we know the total probability is 1. Okay, so we can just subtract those 0, 1, and 2 from 1 and get the information. I mean, it will actually equal to the sum of r equal to 3, 4, 5, and 6. You got what I mean? So that's why here, the solution given, because we know already the value of A and B and C, this one. So more than 2 machines, you can just subtract from one the values of others that are less than 2, which is 0, 1, and 2. Okay, so here 1 minus the summation of this, yeah, 0.2621, 3932, 2458, and this is the value of it, and this is actually the answer. And this is actually represents the summation of this. If you want to find from R3, R4, R5, R6 also can, but is since in this case you have solved A, B, and C, so you can just subtract it, yeah, knowing that the total probability is 1 or 100%. So this is another information that you have to know by yourself. Know yourself, okay? Without knowing, without having this information, you cannot use this formula. Okay, so that is binomial probability. Okay, another way, this is based on formula, right? We apply this formula, we solve it, yeah, to find this answer. So apart from the formula, we can also use table that have been created by statistician. How they create this table? They created this table based on the formula. They come up with a formula first, and after they have come up with a formula, they find the values of whatever, you know, the situation it is, and they put it in the table. It's actually to ease us, so that we don't have to use the formula. But of course, in order for you to understand, you have to know the basics is actually started with this formula. So an alternative way, if let's say you don't want to use the formula, you can use what we call binomial distribution table. So this is a table. The information given here, there is N, there is R, and there is also P. Yeah. So these are all the parameters that we identified from the formula just now, right? So let's say in this case just now, let's say we don't want to use this formula. We want to solve the first question. We know that the R is 0, P is 0.2, N is 6. Okay, how are we going to use it? So N is 6, okay, this one. P is 0.2, this is 0.2. So this is the column that you need to refer. And let's say for the first question, R equal to 0. The value is 0.2621, which is equal to this, isn't it? So it's much easier. You don't have to solve the equation. R equal to 1. R equal to 1 is the second value here, 3932, which is this one. The same, it's the same actually, because they created this table based on the formula. And the third one is 0.2458. Okay, so let's say just now, if let's say you do not want to use this this formula, you want to solve R3, R4, R5, R6, you can use the values given here actually. This one, this one, this one, and this one. If let's say you sum up all of these values, you will find it is actually equal to this one. Understand? Okay, so normally in the exam, you just have to use the table. But here, we introduce first the formula in order for you to know that the formula is the basic of the table. Okay, any question for this?
No.
Okay, I just go directly because I want to make it shorter. Okay, then the second one, the second distribution is Poisson distribution. So what's the difference between binomial and Poisson? It's actually the same, but actually Poisson is just an extension from binomial. So whenever the n is greater than or equal to 20, we use Poisson. Okay, so just now you see the examples here, the n is only 6, right? So it's small. So anything when the n is less than 20, you use binomial. When n is equal or more than 20, you use Poisson. That's the difference, the only difference. But actually, it is an extension of binomial. Okay, this is the formula of binomial. So for Poisson, what I can say, what you should know, it has its own formula, which is actually much simpler. So this is the formula for the Poisson. Okay, Poisson. So what it has in this formula, E is the constant. So if you go to your calculator, you can see that there is a E, right? E to the power of something. So you can you can use that button. Okay, you can use that button to find what's the value. So E is a constant. What you have to know is the lambda. Lambda is the average number of events, or the mean. This one, the lambda. And then R. R is the number of the events that you are analyzing. The same thing like binomial just now. So if you are analyzing P, only one, one event, the R is 1. Then it depends on the questions. Okay, the variable number of events. So the only thing that you have to know here is the lambda, the average number. So it doesn't have n because the nature of Poisson is for big number of data, more than 20. So it's not concerned with n. Yeah. Okay, let's have a look at example directly. The safety of a dangerous intersection was being investigated. Past police records indicate a mean of 3 accidents per month happen at this intersection. The number of accidents is distributed according to Poisson distribution. Okay, now in this question, it is stated directly that is the distribution is Poisson. So you don't have any doubt. You can just use Poisson principles directly. Okay, but now we have to analyze what are the information given because we want to use the formula. Or, okay, I introduced first the formula. It also has Poisson table. Okay, let's have a look at the formula first. So here, a mean of 3 accidents per month. This is actually the lambda value. So remember when average number of events or the mean is actually the mean, okay, the lambda. So that's lambda. So here is lambda equal to 3. Okay, what else? There's nothing more. Okay, let's have a look at the first one. The highway wants us to calculate the probability. We are still talking about probability. Probability means that it must be less than 1, the values, probability, in any month of exactly 0, 1, 2, 3, 4, and 5 or more accidents happening. So this is actually R. This is actually R. So means that you want to find what's the probability when R equal to 0, R equal to 1, 2, 3, 4, and 5. Okay, so this is the formula. So you know lambda equal to 3, E is a constant, and then R is based on the things that you are analyzing. So let's have a look at P equal to, when R equal to 0 first. Okay. This is R equal to 0, okay. So how you want to substitute the information into the formula? E to the power of minus 3, lambda is 3, remember? So R is 0, so that's why it's 0 here. And this one 0 factorial, R, yeah? So this one is equal to 1, right? So this one is equal to 1. Anything with the power of 0 is equal to 1 as well. This one you have to know by yourself. Okay, so at the end, you just have to solve this term, right? 2.718 is the value of E. Okay, so when you insert in the calculator, you can just go for E to the power of minus 3 actually. So you got this value for P equal to 0, for R equal to 0. So R equal to 1, you do the same, but just substitute the value of R into the formula, you got this value. Okay, and until you got until 5, right? Okay, so each of that has its own probability value. This is probability. Yeah? Right. So the last question, 5 or more accidents happening. Okay, let's say more than 5, it means 6 and above, right? And because this is a discrete distribution, we don't talk about 5.1, 5.2, 5.3. There's no such thing. So we start directly with the whole number after 5, which is 6. So if let's say if you want to calculate P6 or more, okay, just now for the binomial, it's still possible for us to, let's say we want to find the probability of more than 2. And let's say it's given 6, n equal to 6, right? So we can find what is R equal to 3 plus P R equal to 4 plus R equal to 5 until P R equal to 6. It is still possible for us to find it if let's say we don't want to subtract from 1 because we know that the n is equal to 6. But for Poisson distribution, because the nature of Poisson distribution is for large distribution, we do not know what's the n from in this case. We do not know what's the n. So we don't have choice. We cannot solve it one by one. But what we have to do is that anything more than 5, we can just subtract from 1. Okay, let's say we have the information from here, from 0 to 5. So you add up all of those things, right? So this is from this information. And then the probability of 6 or more is equal to 1 minus the summation of all of this probability. Then you get this information. Okay. So yeah, it's impossible for us. We do not know what's n. N could be 100, n could be 20, 50, but we don't have the information of that. Yeah? So that's why we use this formula directly. Okay. Right, if let's say we want to say more than 3 accidents, so it means that more than 3 and above, it means it starts with 4, right? 4. So if we want to find the probability of more than 3 accidents, we have to subtract those that is p equal to 0, 1, 2, and 3. So you just don't forget this r equal to 0 is also included. Because some of the common mistakes done by the students, they just consider r equal to 1, r equal to 2, r equal to 3, but they forgot about r equal to 0. This one is also included because the probability of there is no accident, for example, r equal to 0, is also a probability. So you have to consider that as well. So that's why it is included in this calculation. Okay, more than 3 accidents. So this is the value. So yeah, so this is based on the formula. So same as the binomial, if you don't want to use formula, which is always the case for exam, you can refer to Poisson distribution table. So there is a table for it, and how they create this table is based on the formula tadi lah. So they create the values already, they calculate already all the values so that you don't have to calculate manually. And whenever you just need the information, you just refer to the table. So that is the purpose of the table. And because of this one, it is called standard distribution because it's based on the formula. They have they create the table based on the formula, and the distribution, the whole distribution is called standard distribution. Okay. So this is the table. So what's the information provided is r. There's r value. There's lambda value. Okay, let's say just now we don't want to use the formula. We want to solve it using table. So we know that the r is the lambda is equal to 3, and let's say for r equal to 0, it should be the same. Sorry, it should be, kalau kita tengok dalam table tu, it should be this one lah. It should be similar lah. So let's say from the table, r equal to 0, lambda equal to 3. So this is the value. 0.0498, which is similar to the one that we calculate manually. And r equal to 1, this is the value, 0.494, and so on. Okay, so it's much easier actually to refer to the table. Okay, so that is Poisson distribution and the Poisson table. Okay, there is another case. This is the last one. When we want to use Poisson distribution as an approximation of the binomial. Okay, wait. Okay, whenever it is, it says that we want to use Poisson as an approximation to binomial. What we have to do, it should the distribution should satisfy certain conditions. The first one is the p should be less or equal to 0.05, and then how are we going to find the mean? Because for the let's say binomial is not stated the mean, we have to use this formula. Okay, the lambda equal to n times p. Okay, so let's have a look at the example of the question. Given a binomial distribution with n equal to 28 trials and p equal to 0.025, use the Poisson approximation to the binomial to find p r greater than 3 or equal to 3, r equal to 6, r equal to 9. Okay, so it is stated there that you have to use Poisson approximation to the binomial. So in that case, you have to apply this one yang rule tadi tu. You have to check whether the p is less or not than 0.05. Yes, it is, right, for this one. Yes, and then another thing is you have to apply the lambda equal to np before you can use Poisson distribution, because the lambda is not given directly in this situation. Okay, so you have to find what is lambda equal to np. N is equal to 28. P is 0.025, means that here you have to calculate the lambda value rather than the lambda value is given, like the example before, the lambda is given. So this one you have to find it. So in this case, it's 0.7. Okay, so only then you can use the Poisson distribution to solve this problem. Okay, and how you solve it is the same lah. Tadi, kalau r equal to greater than 3, then you have to refer to the table. If let's say you refer to the table, refer to the r equal to 0.7 first, and then for r greater than 3, so you have to consider this value. You have to subtract from 1, so you have to find this one first, this and this, because that's referred to r equal to 0, r equal to 1, r equal to 2. Yeah, so you want to find 3 and above, right? So you have to subtract this one from 1. Okay, so that's why you got it from this one. Okay, and this is the value for this probability. So r equal to 6, that one is quite straightforward. So which is this? Okay, r equal to 6. And then what happened is r equal to 9. Okay, there are some situations where the r value is not available in the table. But how you want to find the value? Okay, if you see here, this value actually refers to, refers to probability. The whole value here, whatever the values in the table, is actually probability. Probability. And if you notice, and it is actually, is less than 1.0. Okay, so if you see the trend here, it means that for r equal to, for lambda equal to 0.7, from r equal to 1 is 0.4966, and it's decreasing, isn't it? Decreasing means that 0.4966, then it's getting lower and lower, 0.3, 0.1, until at this point is 0.0001, and when r equal to 7 is 0 actually. So anything that is more than that, if you expect it to be like 8 or 9 r, even though it's not stated in the table, you can actually predict it is actually 0. Okay, for anything that is less than this, there's no other value more than that anymore. It's not going to be 0.5. It's going to be less than that. And if it is 0, and probability there is no negative values, so it should be 0 lah. It should be 0. Okay, that's why for r equal to 9, it's not, even though r equal to 9 is not here, but you can say it is 0 based on that assumption. Okay, so probability there is no negative values. You cannot say negative 0 point whatever. Okay, so that's how you can answer this question even though it's not stated in the table. Okay, I think that's it. That's the last slide I have. Okay, so basically what we have covered for LU2, we've talked about observed and standard distribution. Observed distribution is the one that we just observe, yeah, as the name implies, we observe. We don't refer to any formula. We don't refer, well, I mean, formula is like any standardized formula for calculating the distribution, the probability. The formula mean, of course, it has formula, but what I talk about here is the way how we want to calculate the probability. There's no like, you know, like formula for the binomial just now. For the Poisson, it has its formula to calculate the probability. It has the table. So for observed distribution, it doesn't have such things. But for standard distribution, standard is when it comes to here actually. So we have examples binomial and Poisson, and both of these is discrete distribution. Discrete distribution. How to know that discrete distribution, as tadi lah, kalau let's say you talk about the events, r equal to 1, After that is r equal to 2, r equal to 3. So there's no r equal to 1.5, 1.6. There's no decimal points. It's whole number. Discrete is whole number. Yeah. So that is binomial and Poisson. So what you should understand from this, for the observed distribution, like how to find probability, yeah, probability of whatever the things or events, you just divided the frequency with the total number, that is observed distribution. For the binomial and Poisson, you have to know the existence of the formula, and you have to know also that if you don't want to use formula, you can use the values, or you can find the values of probability from the binomial table or the Poisson table, depending on the situation. Okay, binomial is for n less than 20. For Poisson is when n is greater or equal to 20. Okay, so that's it. I will upload the lecture notes on eLib after this. I've already uploaded the binomial and Poisson tables. You can have a look. Okay, any question from LU1 or from today's LU2?
No, doctor.
Okay, all right. So for the exercise, you can try to find your own exercise. You can Google. Okay, so the difference between university life and school life is that at university you are trained to be more independent. Means that okay, we are just guiding you. We're just guiding you. This is the things that you have to cover. This is the thing, but we don't have anything that is called like latte to be, like past year questions. That one is schools. Yeah. Okay, we don't have past year questions for you to present. You have to try find by yourself. We are training you to be independent. So once you, let's say you graduate later, you know how to find information by yourself. So we are not just providing everything, okay? But we are here to guide. We are here to, you can ask me if let's say you understand, you need some explanation, I can explain. But in terms of the exercise, you have to find by yourself lah, and then you have to discuss. You can discuss with your friends. Okay, so but if you didn't know anyone yet, you can ask me lah. Okay, so yeah, thank you for your attention. I'll see you in the next lecture. Okay, all right. So for the attendance, any more attendance? Okay. So just now, the one who needs, okay. If you are done with the attendance, yeah, you can leave. Yeah, thank you very much for your attention. Okay, anything?
Thank you, doctor.
Thank you, doctor. Bye-bye.
Welcome. Bye.
Thank you, doctor.
Thank you, doctor.
Yeah, welcome.
Thank you, doctor.
Yes. Okay.
Thank you, doctor.
All right, welcome.
Excuse me, doktor. Saya ada masalah
Yes.
nak scan.
Okay, what's your name?
Zulfaka.
Sekejap ya.
Yes, saya.
Sekejap, I'm masuk ni. Tak ada. Zulfaka. Okay, I
Yes,
will
sir.
key in your name. Okay. Don't worry.
Okay. Thank you, doktor.
Okay, welcome. Okay. Oh, siapa tanya tadi? Yang Ashikin. Ashikin tanya. Yes, yes. I will upload the lecture notes after this. Okay, welcome. All right, see you next week.